Silicon Valley has this famous, or maybe I should say infamous motto, move fast and break things.
Oh, yeah. The classic battle cry.
Right. It's basically the whole philosophy
Yeah.
of the private tech sector, this idea that, disruption is the absolute ultimate goal.
Well, because it's the engine of rapid iteration, right? I mean, if a new social media feature crashes, or say a food delivery algorithm routes a driver to the completely wrong side of town, it's treated as, a minor inconvenience.
Yeah, just a tiny glitch.
Exactly. The company just patches the software, issues a quick PR apology, and pushes the next update. The friction there is just really minimal.
But when you step out of that fast-paced startup world and into the halls of government, that motto sounds like an absolute nightmare.
A literal nightmare, yes.
Because in the public sector, breaking things doesn't mean a glitchy app on your phone.
Mm.
It means misrouting tax records or compromising classified national security data or...
Disrupting the essential day-to-day services that citizens literally rely on to function.
Exactly. The stakes are just fundamentally different.
They are. I mean, government agencies are essentially trading the luxury of experimentation for the absolute necessity of stability. Think about it. A 99% success rate for a commercial app is a total triumph.
Right. You'd be popping champagne.
But a 99% success rate for a municipal water management system or like a federal benefits distribution network, that means thousands of people are suddenly facing a real crisis.
Okay, let's unpack this. Because there is this immense, unavoidable push for government institutions to adopt artificial intelligence right now so they don't get left behind. But there is an equally massive wall of constraints standing right in the way.
A very tall, very thick wall.
Yeah. So today, our mission is to examine a fascinating piece of intelligence from an April 17, 2026 digest, which features this really standout article from Technology Review.
It's a great piece.
It really is. We're looking at a quiet but massive revolution. Basically how AI is trying to break into some of the most challenging, constrained environments on Earth, the public sector.
And it is such a critical landscape to analyze. I mean, as AI technology advances at this completely breakneck pace, the pressure on the public sector to keep up is enormous.
Oh, definitely.
But understanding that wall of constraints you just mentioned, that is the key to understanding how the future of our society's management will actually operate in practice.
Right. And for you listening, whether you work in a highly regulated industry yourself and you're, dealing with your own version of these headaches, or you are just insanely curious about how your government actually operates behind the scenes, this deep dive is going to reveal exactly how the public sector is attempting to modernize without breaking society in the process.
To really grasp the scope of this, I think we have to transition from the ambition, like the broad dream of bringing AI to the public sector, to the harsh mechanical reality of why it just hasn't been a smooth integration.
Because it really haven't.
No, not at all. The Technology Review article lays out the core constraints that make the public sector uniquely difficult for standard AI. And first and foremost, you are dealing with incredibly stringent security measures and very complex governance structures.
Yeah, and we aren't just talking about, like, a company protecting its proprietary code from a competitor.
Right.
We're talking about protecting the sensitive personal data of millions of citizens, stuff that is governed by strict compliance laws about how that data can even be moved or stored in the first place.
Exactly. Data sovereignty is the major friction point here. In the private sector, a CEO can simply mandate a new AI tool, right? And the company just routes its data to a massive commercial cloud server to be processed.
Super easy.
But in the public sector, you have multiple layers of oversight, public audits, compliance officers. Sending an API call that contains, say, classified defense logistics or personal tax returns out to a third-party commercial server, that is a massive security violation.
It's a non-starter. I was thinking about this, and standard massive AI models, the ones making all the headlines lately, they feel a lot like a Formula One racing engine.
Oh, I like that comparison.
Yeah, they are incredibly powerful, incredibly fast, and they require a massive team of specialized engineers and like highly specific fuel just to turn the ignition. But the public sector, on the other hand, operates much more like a city bus route.
That's a perfect way to put it. The operational parameters are entirely different. I mean, the city bus has to stop at every single corner. It has to be accessible to literally everyone.
Right?
It runs on a highly scrutinized municipal budget. And above all, it just has to be reliable.
Right. You can't just drop an F1 engine into a city bus and expect it to pick up passengers safely.
No, that would be a disaster.
The F1 engine might be this absolute marvel of engineering, but it is completely useless for getting 50 people to work safely in the morning traffic. The operational mismatch is just total. But wait, let me push back on this for a second. Isn't AI supposed to be this magical fix-all? Like, why can't the government just buy the same massive models the private sector uses and just, I don't know, put them on a secure computer?
Well, this raises an important question, and it's one the source addresses directly when looking at why massive language models fail in these environments. It comes down to what those models actually require to function at a mechanical level.
Okay, what do they mean?
Massive language models require substantial computational power. We are talking about severe hardware scarcity here. Specifically, those advanced GPUs required to process billions of parameters, along with the massive energy consumption and cooling infrastructure needed just to keep those servers from melting down.
Oh, right, which translates directly to budgets.
Exactly.
A municipal government or even a massive federal agency does not have a blank check to just hoard advanced GPUs or pay for millions of queries running through an energy-hungry commercial model.
Budget is a huge barrier, yes, but the security mechanism is the absolute deal breaker. Massive language models function by absorbing and processing vast oceans of data, and they often learn from the prompts they are given.
Which is terrifying for a government agency.
Right. For a massive commercial model to work, it usually sends that data back to a centralized cloud. So if an agency is handling your Social Security data, they literally cannot risk that information bleeding into a generalized commercial model's training parameters.
Because then someone else could ask the model a question and boom, there's your Social Security number.
Precisely. The risk is unacceptable.
So if massive data and offsite cloud computing are the core problems, the logical solution would be to build a model that is intentionally deprived of that vast data. Right?
Exactly.
Well, here's where it gets really interesting. The Technology Review article points out that the public sector isn't just giving up. They are basically bypassing the wall entirely, using purpose-built small language models, or SLMs.
Yes. Small language models are really emerging as the fundamental antidote to the public sector's constraints. Based on the text, these models are entirely different by design.
How so?
Well, by drastically reducing the number of parameters and the scope of the training data, they become highly efficient and adaptable to those really rigid requirements of government operations we were just talking about.
What's fascinating here is how directly they contrast with the massive models. But wait, let me push back on this too for a second.
Okay.
If we intentionally strip away all that general knowledge to make an SLM, don't we strip away the actual, intelligence part of the artificial intelligence? Like, if an SLM only knows, say, municipal zoning laws, isn't it just a glorified search bar? Why are we even still calling this AI?
That is the crucial distinction to make here, the difference between natural language processing and simple data retrieval.
Okay, break that down for me.
A traditional search bar looks for exact keyword matches, right? It doesn't actually understand the context of your question. But an SLM still possesses the deep structural understanding of human language.
Oh, like grammar and syntax.
Yes, grammar, syntax, semantic intent, and reasoning. It understands how to think and how to communicate. It just has a highly restricted vocabulary of facts to draw from.
I see. So it's more like a hyper-specialized translator.
That's a good way to look at it.
Because, like, a massive model is almost like this chaotic, giant public library where you have absolutely no idea who has touched what book, or if a book is even accurate.
Right.
Whereas an SLM is like a highly secure, purpose-built filing cabinet tailored exactly for one government department's needs. It only has exactly what you need, organized perfectly.
That captures the mechanics perfectly. And because that model is smaller and hyper-specialized, the computational demand drops off a cliff.
Oh, because it's not trying to know everything about everything?
Exactly. SLMs don't need a warehouse of supercomputers or constant connections to a commercial cloud. They can often just run on local existing hardware.
And running locally changes the entire game for the public sector.
Yeah.
I mean, if it's running on local hardware, that means it can be hosted entirely behind the agency's own firewall.
Exactly. The data never leaves the building. By operating on a closed network, the SLM completely sidesteps the security hurdle that disqualified the massive models in the first
That's
place.
huge.
It is. An agency can feed it highly classified documents or sensitive citizen data without ever risking an external API call or violating compliance laws.
Okay, but narrowing that training data has to impact the accuracy too, right? Because we hear constantly about massive AI models hallucinating, like making up fake court cases or giving terrible legal advice.
Well, to understand why SLMs are actually safer in that regard, we have to look at the mechanism of a hallucination. It isn't the AI just like daydreaming.
What is it then?
A hallucination is essentially a probabilistic math error. Massive models predict the next logical word based on the vast chaotic training space of the entire internet. Sometimes the math confidently predicts the completely wrong word because its pool of potential answers is just way too broad.
Ah, okay. So if you restrict the pool of potential answers,
You mathematically reduce the vectors for that hallucination.
oh wow.
Yeah. By stripping away all the unnecessary general knowledge, an SLM becomes laser focused. If it was only trained on the exact verified data relevant to a specific agency's operations, it doesn't have the broad, messy internet data to pull a wrong answer from.
It's a highly calibrated tool designed for a specific job.
Precisely.
Okay, so we have this highly secure, efficient, mathematically focused tool. But the major question is always execution. I mean, the government is somewhat infamous for adopting new technology that sounds incredible on paper but gets totally bogged down in bureaucratic execution.
Right, but implementation is the critical next step here. And the source specifically highlights that this is no longer just a theoretical exercise. There is tangible, real-world momentum happening right now.
Really, like actual deployments.
Yes. Public institutions have successfully started deploying these SLMs, and they're creating a clear blueprint for other agencies to follow suit.
The article outlines this shift beautifully. It's
Yeah.
not just a single, rogue IT department running an unapproved experiment in a basement. It's a systematic adoption. We're seeing real success stories where agencies are proving the concept actually works within their unique constraints.
And we need to unpack the ultimate payoff of that implementation because the article details a twofold benefit.
Okay, what's the first one?
The immediate return is enhanced operational efficiency. Public agencies are burdened by unbelievably complex routine tasks. I mean, imagine parsing through thousands of pages of legal compliance documents for a single infrastructure contract,
It's awful.
or categorizing millions of citizen requests across dozens of different municipal departments.
Yeah, that kind of manual review process usually takes human bureaucrats weeks, if not months, to clear. That's why government feels so slow.
Exactly. But an SLM can process, categorize, and summarize that hyper-specific data locally in a fraction of the time. It is saving an incredible amount of resources, which allows human workers to focus on complex decision-making rather than just basic data sorting.
Doing more with less. That is exactly the kind of operational efficiency that constrained municipal budgets desperately need. But the article points out a second, arguably more important payoff, right?
It does. The strategic payoff is that leveraging AI in this focused manner actually paves the way for more transparent and accountable governance.
Okay, transparency and AI. Now, that is a combination you rarely hear in the same sentence.
Very true.
Usually, AI is criticized for being this impenetrable black box, right? Like, data goes in and a decision comes out, and nobody, not even the engineers who built it, can explain the exact logic path the machine took to get there. How does shrinking the model change that dynamic?
It changes the dynamic because of scope and traceability. If an AI model has processed the entire internet, tracing the origin of a specific output through billions of parameters is nearly impossible.
Right, it's just a sea of data.
But if an SLM is purpose-built and it's trained only on a specific curated walled garden of government regulations, its logic is inherently restricted to that specific data set.
So a human auditor can actually verify the machine's work.
Yes. When the SLM makes a categorization or summarizes a compliance issue, an auditor can look at the output and map it directly back to the specific local documents the AI used to generate that answer.
Wow.
It creates an auditable logic trail. And in the public sector, accountability isn't just a nice feature to have, it is the absolute foundation of public trust.
So what does this all mean? For you listening right now, this represents a massive paradigm shift. This strategic, constrained use of AI proves that technological progress doesn't actually have to mean sacrificing security or accountability.
It fundamentally rejects the false binary that organizations must choose between innovating and staying safe.
You can have both. provided you engineer the right tool for the specific environment. And honestly, that is a lesson you can apply directly to your own constrained projects, whether you're in corporate compliance, healthcare, logistics, whatever.
Absolutely.
You don't always need the massive, energy-hungry, overly complex solution that's dominating the news cycle. Sometimes the intentionally constrained, highly secure, focused tool is what actually gets the job done without breaking the system.
It is a profound lesson in the power of constraints. The massive roadblocks of the public sector didn't stop AI adoption. They forced the technology to evolve into something more responsible, more secure, and ultimately more auditable.
Well said.
Yeah.
Let's wrap up this journey we've been on today. We started with what looked like an impossible task, right? Bringing the power of artificial intelligence into the heavily constrained, highly regulated public sector without adopting the move fast and break things chaos of Silicon Valley.
Right.
We broke down why the massive F1 engine language models are simply too risky, requiring those external cloud APIs, massive compute resources, and posing just unacceptable data sovereignty risks.
And from those severe constraints, we examined the rise of the antidote purpose-built small language models. We unpacked how their focused training drastically reduces computational load, allows for secure local hosting behind agency firewalls, and fundamentally limits hallucinations.
Providing a safe and highly efficient path forward. It's incredible to see how a seemingly insurmountable wall just required a completely different kind of engineering approach to bypass.
If we connect this to the bigger picture, the implications are vast. AI's potential to transform even the most rigid, slow-moving, and constrained environments is becoming undeniably evident.
Yeah.
If these tailored models can successfully navigate the intense red tape and security protocols of the government, their potential applications in other highly regulated fields like global finance or clinical healthcare are virtually limitless. We are actively transitioning from an era of general sprawling AI to an era of specialized, secure AI.
And as that era unfolds, I want to leave you with a final provocative thought to mull over. We've spent this entire deep dive looking at how governments are utilizing these highly secure, hyper-tailored small language models to parse their own regulations and make their internal governance more efficient. But think about the flip side of that equation. If these SLMs are so efficient, so focused, and so capable of navigating intense bureaucratic red tape, what happens when these same purpose-built models become available to everyday citizens?
Oh, that's an interesting thought.
Right. What happens to the balance of power when you can use your own personal, locally hosted SLM to audit your government's decisions, or instantly trace public spending against municipal codes, or navigate the exact bureaucracy that used to be a barrier to entry?
Equipping the public with the exact same analytical power as the state would be a fascinating shift in civic engagement.
It really would. Moving from an era of move fast and break things to an era of move carefully and illuminate things. Thank you so much for joining us on this deep dive into the April 2026 Digest and the Technology Review findings. We hope this gave you a new lens on how the tools of tomorrow are being reshaped by the constraints of today. Until next time, stay curious and keep exploring.